Hi, how are you doing? This is Tylee, recording the section of improper integrals. What I want to look at is second part of, by second part, it is very substantial, but second part of improper integrals, which deals with a function that has a divergent portion of it in the middle of the function, domain. Not saying that the disconnected part is included in domain. So, what I want to do in this problem is to realize that at x equals 4 there is a vertical asymptote, and I don't want to integrate over a vertical asymptote because that's not possible using FTC1 or FTC2. And what I want to do is subdividing portion into 0 to 4 and 4 to 6. In order to do that, I want to separate this integral to two different integrals, and that is possible because we are including, we're not including 4, but we are including 4 negative and 4 positive, which means right next to the 4, left side of 4, and right side of the 4. Sounds a little awkward, but please take it. And plugging actual values, I get anti-differentiated portion of it, and then I want to use limit as a approaches 4 negative and b approaches 4 positive. I want to separate those variables because 4 negative and 4 positive might bring to the different end of the infinity if it diverges. I'm not sure about it yet, but if it does, we have to be really cautious of separating a and b. So the left portion of the integral will be limiting from 0 to a, and the right side will be limiting from b to 6. And the end result would be of the function would be 3 times x minus 4 to the 1/3, and that doesn't change over time. So I just want to plug a0 b6 in, and then what I get is something like this. As I plug a, which equals 4 minus, I get 0, something slightly smaller than 0, but which is 0 when the exponential part is like positive. It doesn't even matter. And for the b, the same thing applies, and 0, something really like close to the 0 to the 1/3 would bring it to the 0, because 0 to the something is 0 no matter how big it is, and it's not even big, it's 1/3. By plugging negative 4 in, the value we get is 3 times negative 4 and 3 times 2 to the 1/3. So by approximating, we get something like 8.541. Thanks for watching. Done.